Hello, Algebra 2. Here we are with our second lesson from Unit 8, adding and subtracting rational functions. Okay, rational just means we can express it as a fraction. So let's get started with a little fraction warm-up problem. We have 1/4 plus 2/3 plus 1/2. What would be the common denominator for fourths, thirds, and halves? 2, 3, 4, the first number that all of them go into is 12. So sometimes I like to have it just off to the side like that to remind myself the goal here. So think about what you'd have to multiply all these denominators by to make them be 12. And whatever you multiply the bottom by, you also have to multiply the top by. Okay, so with 4, we have to multiply by 3. And why do I need to do 3 to the top and the bottom? Number 1, to keep it equal. Why is it equal? Because 3 over 3 is 1. And 1 times anything stays itself. So I'm just changed how it looked, multiplying 3 over 3 to 1 over 4. It's still going to be equal to 1/4. Okay, with this one, to get the 3 to be a 12, I need to times by 4. And to get the 6 to be a 12, or the 2 to be a 12, we need to multiply by 6. So just showing my work, we'll have 3 over 12 plus 8 over 12 plus 6 over 12. 3 plus 8 is 11, plus 6 more would make it 17 over 12. Or if you want to get really fancy, we'd have 1 and 5/12. Alright. Okay, now we're going to take that same idea down to here, where we're going to have monomial chunks in each part of our fraction. So we have 4 over 5a to the third b squared plus 9c over 10ab. So with the number parts, we're still looking for the common denominator, or least common multiple. And with 5 and 10, the smallest number that they both go into is 10. Okay, hopefully we can still see that 10 over there. And now with the exponents, or the powers, the variables with powers, if you see that letter, we have to use it. If they both have that letter, then we want the highest exponent. So they both have a, so we need a to the third, that's the biggest one. And they both use b, so we need b squared. So that's our goal. We're trying to get the bottoms and the denominators to be 10, a to the third, b squared. Okay, so on my first one, I need to go times 2 to make that be a 10. The a's are okay and the b's are okay. So we're going to go 2 to the top and the bottom. On this side, they have the 10 already. I just need some bigger powers of a. So ab is like a to the first, b to the first, and I need it to be a to the third and b squared. So I need 2 more powers of a and 1 more b. Okay, I'm going to rewrite it. 2 times 4 on the top, we got 8 over 10, a to the third, b to the second, plus 9, I'm going to put those letters in order, a squared bc over 10, a to the third, b to the second. And now we have a common denominator. And with the monomial problems, what's usually going to happen is you're just going to squish them together over one denominator. You're probably not going to be able to combine anything, because in order to combine things, you'd have to have literally the exact same combination of letters and powers. So it'd have to also be 8a squared bc in order to actually add those together. Okay, usually you won't be able to reduce because all three pieces would have to be reduced or be able to be reduced by the same thing. So like 8, 9, and 10 would all have to be divisible by the same piece. And that usually doesn't happen, but sometimes it does. Alright, let's look at another one with a minus. 16c squared, 5, 8 to the third c. So 16 and 5, the least common multiple, the first number that they both go into is going to be 80. They both have a c. C squared is the biggest. And then this one has an a, so we'll need a to the third as well. So our goal is to make the denominators be 80 a to the third, c to the second. So what would we need to do to the first one? Well, to get to 80, we're going to have to go times 5. It has the c squared. It's missing the a to the third, so I'm also going to need an a to the third. Alright, I was just kind of tight for space on the front with that black line there, so I moved the a to the third to the back. On this one, we're trying to get that to be 80. We're going to need 16 times. And it has a to the third. We need c squared, so we need another c. Okay, just showing work to clean these up. We should have 15 a to the fifth over 80 a to the third c to the second minus 16 times 8 is going to be 128 xc, or you could have cx, it doesn't matter, over 80 a to the third c squared. And again, we're going to combine over one fraction here. Okay, and again, 15, 128, and 80, it does seem like, man, there's got to be something that goes into all three, but there's not. Alright, I think you're ready to try one on your own. Let's go ahead and push pause and give this last one a shot. Ready, set, go. Alright, welcome back. Let's see how you did with that one. Okay, so the goal was to get to 8 x to the third y squared z. Okay, the one on the left is going to need a 4 y squared, and the one on the right needs x squared z. And we should end up with 12y to the third plus 5 x squared z squared over 8 x to the third y to the second z to the first. Alright, good work there. Let's flip it over and try the back side. With the back side, with polynomials, we're going to take the biggest power of each group. Probably not going to have very many today that have powers on the groupings. And if there is a tie, you only write it once. Okay? So this hasn't been very effective today in class, and we've been better off just jumping down to these example problems. Okay, I left a lot of space here so that we can just kind of factor these right in the problem. So x squared minus x minus 6. What's going to multiply to negative 6 and add to negative 1? We're going to go with x minus 3 and x plus 2. And then 5x plus 10. We can take a 5 out of both pieces of that. 5 out in front. X plus 2. Okay, now here's how I like to do these types of problems. Similar to the last set of problems, but just a little bit different. Okay, from these I like to look at what do they both have and what does each one need. Okay, they both have x plus 2, so that's good. So now what does each side need that the other one has? So what does the left side need that the right side has? The right side has a times 5. So the left side will also need a times 5. And if I need a times 5 on the bottom, I also have to do that times 5 on the top. What does the left side have that the right side doesn't? That x minus 3 group. Okay, so if the bottom gets the x minus 3 group, the top also gets the x minus 3 group. And now we have a common denominator. Okay, the order might be a little bit different down there, but it's all multiplication, so the order doesn't matter. 2 times 3 times 4 is the same as 4 times 3 times 2. Now with these, we will multiply out the top, and there will be things to combine. Okay, so we'll have 5x minus 5. And another tricky one here, this minus is going to go with that 4. You could do 4x minus 12 and then take the negative sign to those, or you might as well just take the minus with the 4. We'll have negative 4x plus 12. This is all over our common denominator, 5, x plus 2, x minus 3. And again, that order doesn't matter down there. Okay, we'll clean this up a little bit. We can put the 5x minus 4x, and that will give us 1x. And then we have a negative 5 plus 12 for a plus 7 over our denominator of 5x plus 2, x minus 3. Okay, so where there's not much to do at the end of the front side, the back side, we do have a little bit more work to do at the end. The front side, you did have to think a little bit more with like the denominator situation, and the back side, there's a little bit less thinking about the denominator situation. Okay, also with these, because we do usually have to combine some stuff, it is possible at the end that this would match up with one of these and cancel out. Or if there was like x squareds involved on the top, you might have to refactor the top, and that could also possibly cancel again. So keep your eyes open for that. That doesn't happen very often, but it can. Alright, let's look at another one down here in the middle. Okay, we got a really tricky one right off the bat. 4x squared plus 21x plus 5. We might need to bust out the magic x. Okay, front times back, 4 times 5, what multiplies to 20 and would add to 21. Do. Okay, that's going to be 20 and 1. Now, because we had to do front times back, we also need to come back and divide by that 4. Okay, 20 divided by 4 is a nice 5. So it's going to be x plus 5. 1/4. Okay, the bottom number is going to slide back up in front of x. 4x. And it was a positive 1, so plus 1. 12x plus 3. We can take a 3 out in front. And now we'll have a 4x plus 1. Alright, now there is a little something right there that you could simplify. Maybe you'll catch it, maybe you won't. I'm going to not catch it on purpose so I can show you something at the end. Okay, what does the left side have that the right side needs? They both have 4x plus 1, so this one has an x plus 5 that this one's going to need. And this one has a 3 that this side's going to need. All right. Let's see what we get. So we'll have 3x minus 24. That's a plus, so I don't need to worry about taking that negative sign with it. It's a plus this time, so 6x plus 30. And across the bottom we have our 3, 4x plus 1, x plus 5. Okay, combine our like terms. We'll have 9x plus 6 over 3, 4x plus 1, x plus 5. All right, now double check. Can we simplify this anymore? 9, 6, 3. They're all divisible by 3. Okay, so we can divide all the main numbers there by 3. And now we have 3x plus 2 over just 4x plus 1, x plus 5. Now that was something that we could have handled earlier. Way up here when we took that 3 out, and it was 6 divided by 3, we could have reduced by a 3 right there. And then just had 2 on the top and not had this 3 there. Okay? So because we didn't catch it there, we did catch it here. And that's how our answer simplified to that. Alright, let's have you try this one on your own. I'm going to help you get started with this one. Because if you don't catch this right off the bat, it does make it a little bit trickier. So 4, 14, 6. I can't pull a 4 out, but I can take a 2 out. 2x squared minus 7x plus 3. Okay, now that should be a little bit easier to factor. If you didn't take a 2 out and you just did 4 times 6, you'd make some progress, but you'd also lose a 2 at the end. Okay, so let's push pause and try that one out. Ready, set, go. Alright, welcome back. Let's see how we did with that one. Oh, I'm trying to find a nice handwriting one for you to look at. Okay. So here we are with this one. It should go to 2x minus 1, x minus 3, 2x minus 1, oh, not yet, 6 and x minus 1. Okay, so they both have the x minus 3's, excuse me there. This one's going to need the 2x minus 1, and this one's going to need a times 3. And we'll have 10x minus 5 minus 3x, because that's a minus 3x plus 3. And after we put things together, we'll have 7x minus 2 over 6 times 2x minus 1, x minus 3. Alright folks, thanks for watching. Hopefully that helps. Tomorrow should be just another day 2 work day, fresh worksheet. So give it a good shot on your day 1 worksheet today, and let me know if you have any questions. Thanks for watching, and good luck.